Anupama is there?
Anupama is not there. I think today she's not there. So, no,
Okay.
okay, no problem.
Sir, we are starting.
Welcome everybody to this 8th Water Tech Talk, a niche program of the National Water Mission, which has really got a lot of appreciation, and many people actually, in fact, are now appreciating the quality of the talks which we have come up in this the Water Tech Talk. Can who is Sunil? You are mute कर लीजिएगा आपका Sunil.
Sir.
Okay, mute कर लीजिए. You please mute yourself. Okay, so this is the 8th of the series of the Water Tech Talk. As I said, National Water Mission had been holding these type of talks. The Water Talk, which most of you are aware, we do that every third Friday. 25 water talks are over, and we have very experienced and very known figures in the water field have come and given their talk. Last on 25th Water Talk, we had Mr. Dr. Rajendra Singh, known as the Waterman of India and also the Stockholm Prize winner. We had similarly many people who have got Padma Bhushan, Padma Shri and all participating in the Water Talks earlier. And also we had this, we still have that dialogue with DMs on every Saturdays where we call NGOs and DMs to talk on it. So Water Tech Talk is one very niche event where we thought we will really talk about cutting edge technology to the people, and this would be for the people who really likes to know the cutting edge of technology in the water sector. So we have been quite successful in that. In the last 7 talks, we had extremely very high quality people presenting, except for once when this particular talk of Dr. Ghosh had to be cancelled because of a very unfortunate situation, and we had to scramble for a person. Otherwise, all the talks had been of extremely high quality and very high technical matter, like talk by Pradeep from IIT Chennai. Then we had from Australian Ekagen of the Swedish Environment and Research Institute, Sweden. We had from IIT Kharagpur. Last week we had last Water Talk was by Dr. Nupur Bahadur on TADOX. So very innovative, different set of aspects of it. Now, one more minute, I'll take on the Catch the Rain campaign. This is the campaign which the Honorable Prime Minister had launched on March 22nd, a very big campaign, probably the biggest ever launch in the world on water sector, conservation sector, where he addressed 2.5 lakh Gram Panchayats and Gram Pradhans, DMs, and the Gram Panchayat, in the Gram Sabha, a lot of villages also were there. So it was a huge campaign where he launched the campaign to catch the rain where it falls, when it falls. It had been going on well. It is going on well, though it is a little bit hampered by the COVID crisis, where we have problem of collective working. Nevertheless, a lot of work is happening in the individual field, and many places where work is possible, a lot of work is being taken up. So our efforts on catching the rain is also going very well and very fruitfully, and we had actually 2-3 meetings of the NGOs, nearly 50-55 NGOs, more than 100 NGOs participated in our meetings. So that is the ongoing program. And coming to this today's topic of on the Glacier and on providing technical advice and assistance, on the topic for today's is very contemporary, because this is something which happened in a couple of months back, which really reinforces our memory. One of the main goals of National Water Mission is to study impact of climate change on water resources. Though we had been doing a lot of other activities, this is one area which we had been sort of missing it out. And the impact of climate change on water is very severe. Most of us are aware how the rainfall pattern has changed, how the intensity of rainfall has increased, how the water with the high intensity rainfall is creating problems of less water storage, and that's why we have to start this Catch the Rain campaign also. That's one aspect of it. Not only that, the impact of melting of snow these are all things which are now, we are feeling the pinch of it, and we are now beginning to take it seriously. And as a grim reminder, we had an event which happened on February 7th, 2021, where there was a burst of in Chamoli, in a rainy village. There was a burst of a glacier, and that many theories are there. It's said it's a glacier lake outburst linked flood. Whatever it is, they're still studying about it. These are all highly technical topic, and that's why we have the expert in that field coming and talk to us today. Dr. Ghosh is from he's Dr. Ashwagoshi Ganju. He was a director of an institute called Snow and Avalanche Study Establishment, which is started in 1969, part of the DRDO. A very, very noble and very, very important task they're supposed to do. They were to provide research on avalanche, snow, and forecasting support to army and civilians on various issues related to snow and avalanche. And the institute later got merged with the Defense Terrain Research Lab, and it's now become part of the Defense Geological Research Establishment, DGRS. This institute is tasked with very, very highly technical task of providing technical advice and assistance to the army and civilian in dealing with avalanche, weather forecasting in snowfall areas, and research in crevasse formation in glaciers and for rescue and relief operations in those areas, studying of application of mountain weathers for forecasting systems, developing of slope stabilizing techniques, design of avalanche control structures, conducting applied research in snow physics and mechanism of avalanche dynamics and avalanche formation. And these are all very, very technical topics which they are doing it. So we have lucky to have Dr. Ashwagoshi Ganju, who is was the director of that, who has also worked extensively, published so much of papers on this topic, very highly technical subject. Very, very interesting models of subjects which he had published in various papers. So like development of novel algorithm for dealing with snowpack density over snow-covered edges of Himalayas, or ice surface velocity using palential velometric techniques, or then like this, many, many technical topics, papers here have been presented, which many of us are not aware, because we are Amjanta who really look at Gadda Khodna and catch the rain and developing small ponds all over the place. But these are all very, very technical topics. And that's why I'm very proud that Dr. Ghosh is with us. So I want to keep the level of this talk also very high, so that it is a very niche topic with people who are actually interested in technology can come us. So I invite Dr. Ashwagoshi Ganju to talk on the topic which he is very, very thorough with, and also very contemporary. The topic is, as I said, the use of in studying various issues related to the ice and this avalanches in Himalayan areas. Over to Dr. Ganju.
Thank you very much, Dr. Ashok Kumar. It was so nice of you to introduce me to the people who are listening to us and watching us. And this is a topic which I had thought some time back. I had prepared it. It was exclusively to check whether we can say something about not avalanches, but water in Himalaya. So Himalayan water is very important for us, and we want to understand more of it. That's why this topic was chosen, so that we have some insight on Himalayan water and what can be done in future about this water. So I have a presentation. In case I am audible to all, then I will start with the presentation. That will give us better perspective of what's going on.
Oh, you're audible. Go ahead. You're audible. Please go ahead.
Could you speak a bit louder, Dr. Ganju?
Yeah, I will do that.
Are you sharing the screen? It's not coming through.
Yeah, I'm trying. It was not coming in the first go. I will try again. Okay, is
Okay.
that visible?
Yes, yes, yes. Thank you.
Okay. So I will be now starting this topic, and I believe I have to look for a pointer, which is not visible to me right now. Okay, my cursor is visible. Okay, I have this topic now in front. It is on principally, I was trying to find out if we can find out how much water is available in snow and ice in our Himalaya. And since it is sort of an indeterminate thing, and we have been trying to find out what can be done and how much water is available, at what rate it is available, so that the Himalayan ecosystem that's existing as on date can be further, looked into, and in case we have some challenges due to climate change, so what can be done to ensure that this does not happen. Now, as you know, that global water availability is very small. The freshwater availability is very small, as you can see in this view graph. And since 97% of the total water availability is salty, it's only a very small fraction, that is 2.5%, as the freshwater is available globally for the entire community. And out of that, only 0.1% of the world water, that is freshwater, available to us is available to Indian community, or the Indian freshwater, I could say. And it's apprehensive that some people are apprehensive that it may further get reduced by 2030 considerably, maybe even half, and that is the problem. So in this view graph, you can see while world over, we can see a lot of water availability in major aquifers is there. But in case of India, it's only the Himalayan portion where we have got sufficient major regional aquifer system existing. And then the green portion that is marked here, it shows that there are some important but complex aquifers existing all over the country. So looking at it, then we see that the water that is available with us is not enough in comparison to the other countries. Of course, some countries are not in a better shape, but we don't have enough water that way. And whatever water is available, we have to look into it. And I'm very happy that Ministry of Jal Shakti has already taken many initiatives, and they are doing very good work throughout the India for looking into this water availability to all over the country. Now, water, which is the contribution of water in various forms that is coming to Indian subcontinent is approximately from snow, it's about 5 to 6%, which is seasonal. It starts sometime in the month of November and lasts till April. And we have ice, which is roughly 3 to 4%, and it maintains the waste flow throughout the year and keeps the rivers flowing. And especially the need is felt after the cessation of snow melt till the onset of monsoon. This ice melt is available to us, and that way we are getting this ice and snow melt is available to us. But the major portion for the entire country, it's the water coming from rain, that is Indian summer monsoon, which is roughly about 80 to 90%. But this water availability is a little complex if we look at it in the total perspective, especially from the snow melt point of view. We have this water available to us in the month of Feb and March when summer monsoon is not there. And it may extend even up to April, May, or June, depending on when the onset of monsoon has been there. And that way, this snow melt and this ice melt comes handy, and we get water during this period, the lean period or the summer period. The ice melt, which maintains the base flow throughout the year, is already there. But this ice melt generally starts from May, June onwards, or when the summer monsoon sets in. So this period is generally, we can say about April, May, or June, when we have, before the summer monsoon sets in, this ice melt is available to us when we are using this ice melt water, besides occasional rain that keeps on happening in the Himalayan region. But the monsoon rain, that is summer monsoon rain, it starts from June and September. Then we have sufficient copious amount of water available all over the country. So we have annual water yield in India, in Himalaya, is about 8.6 million cubic meters. Now, looking at this graph, you can see this entire green portion, which is dark green portion, this where from this water is coming. And when we're looking at its availability to us in Himalayan availability and the yield, I was going through recently an article which had been published in India Today, and I found that per capita water availability in India was in 70s. It was about 5,000 cubic meter, but subsequently now we are looking in 2020, it's 1,500 cubic meter only. And because of this thing, the water scarcity, which is growing, and now people are looking seriously into it, about 600 million people are facing extreme water stress today, out of about 1,400 million people. And in terms of districts, about 735 districts, 235 are water stressed. And Niti Aayog had recently estimated that 21 major cities, including Delhi, would run out of groundwater by 2030. Actually, I wanted to bring in these 2-3 points because I wanted to emphasize that there is crisis. There is a need to look into it in detail, and that's why we are here talking about it. Now, when we look at the various water which is available to us from Himalaya, we found that from the literature, water which has been given, the estimates which have been given by different workers in different parts of Himalaya are varying. I mean, different people have used different methods of measuring water availability of water from snow as well as ice. So I see that there is a lot of variability and we are not getting something consistent. It should have been a consistent values from all over the people, even if different methods or methodology is being used. Like in this table, which is published by Dr. Jilani, we see that in upper Indus, whereas snow and ice contribution is about 72%, out of that snow is 40 and glacier is 32. And this has been published by Immerzil. Similarly, many other people have done a lot of work in Himalaya, and they have given different values. Out of that, we see that snow and ice contribution is definitely there from the Himalayan belt, and which has been further, segregated into snow component and the glacier component, and the rainfall component that's also there. But looking at all these 3 columns which are in front of you, you can see that the values which have been given by different people are varying. They are not consistent, and the component of snow and glacier also is not further given by each one. It is some people have done it, some people have not done it. So as a result, we are not very sure what is there and what is not there and how much it is available. So my point today is only to emphasize that if we have to look into it in detail, we should start looking at now. And this water is very valuable, and we should be taking stock of it, what it is, and how we can make use of it. The glacier melt component versus snow melt component and the rain, why we are talking about it? It is because this glacier melt component maintains a continuous base flow. And second point is its contribution is during summer period when we need it most. And it also compensates during lean or delayed monsoon periods. So for that, it's important to know the contribution of base flow and the rate at which it's available. Also important to know the contribution of base and surface flow, which happens generally in the month of March, April. And how would this contribution change with the changing glacier area and the thickness? There are certain models, but not enough, and there is a lot of variability in this. And how long this contribution will last with the changing climatic conditions? This is another thing that need to be looked at. So I picked up a view graph here given by Luz et al. In 2014. And here you can see that when we look at the Glacier Bed contribution by flow, given in the A part here in the top view graph here, is maximum is in the northwestern region of Himalaya, where we get the glacier melt. And this rainfall melt is more or less distributed, and it is about 50%, in some places about 80 to 90%, but generally it is about 50% and less than that south of the Himalayan belt. But when it comes to the rainfall, we have again in the northwestern Himalaya a lot of contribution of rainfall, which feed the major river systems or major streams in Indian Himalayan region. Some portion in the central Himalaya also, and some portion in the eastern Himalaya. So you can see now, though snowfall is not widespread all along the Himalayan belt, and it's not uniformly distributed. Nevertheless, we have the snowfall contribution very small in comparison to the snow melt contribution and the rainfall contribution. So looking at it, it's very important that we should develop a state-of-the-art technology for continuous monitoring of area and thickness of glaciers contributing in the base flow and surface melt in North Indian river system. There are many aspects that one needs to look into this whole gamut of activities that happens with the Himalaya in terms of snow and ice. So these are the snow and ice study, and to get a complete picture of what is happening there, there are so many aspects that one needs to look into in terms of ice dynamics and energy exchange and paleoclimate, how it has been there, aerosol interaction, meltwater and hydrodynamics conspiration. There are various hazards, and they impact also on the water availability. Similarly, albedo and carbon reflectance, these are various aspects. But the aspect which is more important for us for today's presentation or today's talk is snow water ice storage and its availability. So we'll talk more on this aspect now. This is a view graph in front. I am showing the type of variability we come across in Himalaya. If we cut across the Himalayan region as shown in this view graph, you can see the perspective view of Himalaya, which is shown in the right corner of this view graph. There are different ranges. The first range is the Pir Panjal range, light brown, and then yellowish is the Great Himalayan. Then we have bluish range marked as Zanskar range. Then we have Ladakh range in the purple, and then on top is the Karakoram range. If we draw an L section all across the Himalaya, we'll see that Pir Panjal has got average altitude roughly about 3,000 meters, and then we have Great Himalayan, which is about 4,500 meters, and Zanskar is close to 5,000 meters. And leaving aside Ladakh range a little bit, which is slightly less, 4,500 to 5,000 meters, we have got further up in the north. It is Karakoram range, which is around 5,500 meters. So you have different altitude ranges. So there is as such a variability in terrain in terms of altitude as well as in terms of different topographic conditions which are existing. So there is a variability of terrain. Also, there is a variability of precipitation and temperature, because this Pir Panjal range, that is the first range that we come across, receives maximum precipitation from snow during winter months. Snow is precipitated. Whereas the next range, which is Great Himalayan range, it receives slightly lesser, but here the snow builds up and stays there for a longer period because of the temperature conditions. Similarly, further up, the temperature further drops, and snow that we receive further up is a little lesser, but at the same time, it stays for a longer duration. So there is variability in precipitation and temperature. The weather system that operates in this part of the Himalaya and the rest of the Himalaya as well is very dynamic. Sometimes the WDs or the western disturbances, we call them, as well as Indian monsoon system or Indian summer monsoon also interact in a very complex manner, that we get snow as well as rain at times. And we have also seen from the past record that both Indian summer monsoon and western disturbances have contributed and brought that distribution of snow and ice or glaciation that we see today in the Himalayas, and it is very widespread as well as it's very variable. So the gross value we at present from the literature that we see is that the gross value of stored water as snow and ice in Himalaya is a lot of variation. And there is a need to have precise values. That's what I was emphasizing on. To further bring home the point of how it is variable, you can see in Pir Panjal, the green graph that is shown here of the lower Himalayan range. The vertical bars represent the snow amount that we receive in different months. So there is huge snow. On x-axis is a small value here, figure you may not see it, but it's 500 centimeters. You can see how different months receive snowfall in the Pir Panjal, average Pir Panjal range. Whereas for the same period in the Great Himalayan Range or the Middle Himalayan Range, we find that it can go maximum up to 200 centimeters or so. But further up, when we go in the Karakoram Mountains or Ladakh Range, you can see that it's very small. It's less than 50 centimeters or so on average. Whereas in terms of temperature, temperature dips up to -10 degrees in Pir Panjal Range, whereas it can go up to -25, 30 in the Great Himalayan Range or the Middle Himalayan Range, and temperature further dips to 40, 45, -45 in the Upper Himalayan Range. So this sort of variability as it is existing in the Himalaya brings a lot of variability in the precipitation also and the storage of water. So there is an immediate need to study both snow, ice, water storage. Now there are certain facts which we should keep in mind. Temperature rise is established in Himalaya. There are small glaciers which are receding and shrinking fast. Precipitation variation, which is now visible, and it can be measured also through satellite data, and some field measurements have been also done. There is a shift in the climate that's very apparent now, and there has been of late erratic precipitation pattern observed in the Himalayan belt. And for all these, some scientific explanation is there, but not yet fully established. So there is a variability. We are getting a trend is showing precipitation is decreasing. So we need to look into a little detail. So there are certain unanswered questions now. Let us look at the questions which have not been answered. How much glacier water is stored in the air? I will come back to this question later on, because there are people now who have done this work, and we only wanted to emphasize here that the information that is provided to us is not complete yet. What is the exact proportion of ice and water in Himalaya? The third question is, how is the strength of Indian summer monsoon and WDs linked to seasonal snowfall and the feedback impacting energy balance? Why are some glaciers in the Indian region advancing while majority are receding or retreating? There is a discharge variation also. Are Himalayan glaciers dropped buffer, and to what extent? Why is glacier mass balance positive or negative of some glaciers in similar regions? So these are the questions which has intrigued the scientists, and they are on pursuit for finding the answers. Some answers have been found out, but not enough as on date. So the question then further from this thing, we further have some couple of questions more. That is, would successive prolonged summers or drought years melt glaciers alarmingly or completely? Would glacier retreat at lower elevations have minimal effect downstream? And how is the future glacier evolution likely to be? Various people have already worked on. And how is the future sea level contribution likely to be as a result of this change? And from these two questions that we have got, two sets of questions we have got, the question that is now left with us is that what is the supplemental data that required to be picked up with the help of which we can plug the gaps which are existing as on today. There is strategic importance of both snow and ice water. Water energy storage shall be the prime concern in future, at least in dozen countries, including India. And there is a need or strategy, there has to be a strategy to manage shrinking resources in the face of growing population and climate change. And we have to use the new technology. So from this, we come on to some relevant facts. In Himalayan region, that is HKH region, drinking and irrigation and other water usage, it provides to about 1.5 billion people, 700 million people in Indian Himalaya. Then China and India contain about 37% of world population, but only 10% of known freshwater resources. Drought years, which you have seen in the river Danube, when there was a drought in 2003, it had taken a lot of water from the glaciers. So would that sort of thing happen here also? Groundwater is not replenishing properly, and increasing use of water by humans, urbanization at rapid pace, shifts in location, intensity, and variability of precipitation is happening. And estimates that we are getting from satellites, that is NOAA satellite, which is estimated to be about 1 millimeter accuracy, is still questionable. And the seasonal snowfall timings and amounts and impact the albedo and the local energy balance, which will have direct impact and indirect effects on glacier mass balance and impacting the timing of river discharge. So the current uncertainties in the state of snow and ice in Himalaya are of concern. Most projections of their future reserve have shown serious consequences for water resources. So these are some of the facts to be borne in mind when we proceed further. And there are certain geopolitical consequences also. With water security, then there will be security threat. With water scarcity, there will be security threat. It's connected with food scarcity and then security as well. There is rise in natural hazard, as has been brought out by Dr. Ashok Kumar also, and then Himalayan dense desertification may accelerate in some areas, so some areas may get open. Then retreating glaciers may destabilize slopes, dam streams, which is happening. We have seen some examples. Hydropower may suffer, increasing vulnerability downstream, extreme runoff, increase in GLOF, damage to Himalayan lowland, and forced migration of the people to plains, and then water conflicts, which is obviously may happen in case we have got water scarcity from this region. So these are certain geopolitical issues. And what is really unknown now in Himalaya is that why some glaciers are advancing. This is very intriguing, and some of the insight has been already brought out by Dr. Bamri when he said that it is associated with the surge type of flow and the instabilities that exist in this part of the glaciated terrain. And energy budget of the glaciated region is not complete. We have got some data from some glaciers, not complete glaciated terrain. There is a gap in the knowledge of short and long-term implications of impact of climate on water and hazards in Himalaya. And the information that is fragmented with us today, the observation is also not sufficient, and the projections that have been drawn are also not complete. So there is definitely paucity of scientific studies, and the reporting, which are reporting changes, is there. The capacity for adapting to future climate change is also not known. So with this background, with this knowledge, you may have got some idea that how is the scenario as on today in Himalaya and what needs to be done. We'll look into it further. And I was looking in the literature that different people have worked in different parts of Himalaya, and they have given us some estimates of ice volume which is existing in the Himalayan region. The work by Frey et al. Is given here, and you can see the total volume which is given by him and Frey, as well as other people who are working, is shown in the first block of these vertical bands. you can see there is a lot of variability. And in terms of individual regions, that is Karakoram, Western Himalaya, Central Himalaya, and Eastern Himalaya, you can see that there also exists a lot of variability. In Karakoram itself, if you can see that there is the reporting is from 2,827 cubic kilometers to about 1,683 kilometers, and different people have used different models and that sort of variability. Whereas we see that in Western Himalaya and Central Himalaya, though the variability reduces quite a bit, and further in the Eastern Himalaya, it reduces significantly. Nevertheless, there is a lot of variability with respect to the different estimates that have been drawn by the people. Our initial work that was done by some of the people initially, like Gupta and Kawasa, they had given us flow estimates of the Himalayan water of the order of about 8,634 cubic kilometer. Subsequently, by Murthy and Bahadur and Alford, the values are 200, 500, and 500. Bahadur later on re-evaluated the whole thing and found it's of the order of 400 to 800. So I wanted to highlight that we have got a lot of variability as on date with respect to the data, the information that is available with us. And long back, I know Dr. Upadhyay had worked in Himalaya, and he also found different regions, and he estimated the volume of the water. I mean, in Himalaya is roughly in Karakoram region, it was 2,180. Whereas we can see that in Karakoram by various other people is close to the value which he had worked up earlier, but still there is a lot of variability. So this is a little concern now, and how can we look into it? Here again, I wanted to mention that this variability estimates in the Himalaya, volume in Himalaya, estimates of ice volume in Himalaya, different people in the different regions, I will like to show you here what sort of variability the values the people have given. Like in the first line here itself, one is the statement which has been drawn by IPCC that would be about 29% lost, 2% gain by 2035. But if you look at these values, it's in the range of 3,800 to 4,850 cubic kilometers for Pakistan, India, Nepal, and Bhutan. And this has been given by Omura in 2009, and I have tried to show it in the Himalayan belt, which region it encompasses. Similarly, in HK region, the values are in this range, and the entire Himalayan range, the values are in this range. And the entire Karakoram Mountains, given by Frey et al., is about 3,000 to 4,700. And some recent work done by RDC Singh, he chose an area where the glaciers are exactly present, and in that he found it's roughly about 1,400 cubic kilometer. And one of my colleagues some time back, he worked in the Karakoram Mountains, he found it's of the range of 1,600. So this thing that you see here is the variability that we see in the mountains. And similarly for Southeast Asia and as well as Southwest Asia, different people have given the values which are shown in the graph below. It includes the values by Huss and Faranotti, Marzion and Grinstead and Reddy et al. These are the values given by different people. So from this graph, you are not in a position to appreciate that we have got different values by different people. So we don't have a very good comprehensive picture of Himalayan ice which is available, ice volume which is available in Himalaya, how it is. And we have another thing is that the glaciers that are showing a negative mass balance for some time, and this is the mass balance from 1960 to 2010, where it has been shown it's been generally negative, and it's has gone down further in 2000 further down. The average value is given by this blue line, and the negative mass budgets on an average for the past decades we see, and Himalayan glaciers are losing at mass at the rate of 6.76 plus minus 1 gigaton per annum, and growing anthropogenic activity, the black carbon by Yasunari has mentioned that about 70 to 200 millimeters of water will be additionally released or additionally meltwater will be available. The deposited soot on the glaciated region is estimated that it may outweigh the greenhouse effect is given by this Cohen et al. And we have hazards due to the moraine dam lakes, ice margin lakes will continue to increase. So there is a dependence on and vulnerability of glacier meltwater or of serious concern, and when measured per head of population in the Himalayan region. And finally, in this series, what sort of variability and how the glacier mass is losing. There is some good work done by people like Kulkarni, and he found out that for various glaciers mentioned here, like Gara, Gorganga, Shanigarang, and Chota Shingri, they found that mass loss of the order of 19-20 meters in these glaciers, and from 1975 to 2011, and it is about 9 to 20 gigaton per year, which has accelerated from this period to this period, and especially from 75 to 2011, we found that about 443 and plus minus 136 gigaton of mass loss has been there in the glaciated region. And some projections which have been drawn for future is that one is that gain and loss by IBC, but 15 to 78% loss is estimated by through RCP 4.5, sorry, and 40% model mean loss is by 2100 is by through RCP 4.5, and 68% if we take RCP 8.5. There is this thing has been happening all over the world, and there is a world mountain glacier loss, and some people have made estimates about 25% from 91 to 2010. So world over, the glacier mass is losing rapidly, and this is the work which has been done by people and published, and we get some insight of what is available. But at the same time, we have got a lot of variations in the results. I wanted to further now in next few slides, I wanted to bring out what are different methods that people have started or used for estimating the glacier ice volume. The different methods are mentioned. I will not go into the methods, but I will name the methods which are here. One is the aerial extent method. It's a power law relationship, which has been used extensively by different people and further modified and fine-tuned, and it's still being used to estimate the the volume of the ice in the glaciated region or any other region. And then some people have further done a good thing about it is that after estimating it through this power law relationship, they did some confirmation methods using GPR, seismic soundings, or deep sea drilling techniques. So there are these methods available. And further, there are certain alternate methods like glacier surface velocity and Glen's law relationship. There is where velocity of the glacier surface is related to the depth of the glacier, height of the glacier. So this is calculated by different methods, for which we use Quasicore method, which is a first registration of optically sensed images done, and then we from that we calculate the velocity, and then further we calculate the depth of the glacier. So this has been done, and people have further taken penetrating radar measurements, and here they have used the velocity, send a wave down, and then from that calculated the depth of the glacier. And if you take a look at this right side graph, which has been shown that by using this GPR point measurements using 155 megahertz gain, we can see the undulations or underneath the glacier, what sort of undulations do we get when we look at the glacier volume or calculate the mass volume. So in case that sort of undulation is there or the variability is there, so all the calculations which is based on previous method, that's power law function, is not correct, is not accurate enough. It will bring a lot of errors in our calculations. Will be I mean, not assessing the volume of water or volume of ice present in the glacier. There are other methods like GLABTOP2 and HF model and OGGM methods, which have been proposed by different people, and the calculations have been drawn. And then the point is now, what are the uncertainties? In power law in relationship, I was mentioning there are certain values. VA scaling, when we look at VA, that means volume and area scaling we do. But when we look into the glacier shape and slope and size, because they are variable, then we found that different variabilities or different constants are being used by different people for different regions. And for velocity, the second method which I was mentioning, glacial surface velocity, the surface velocity of stable ground or estimate has been done. It has been shown by some scientists that it is there. Then the co-registration of Landsat ETM and introduced errors of the order of 5 meters. Quasi-core inaccuracy is about 1.5 meters. Error in glacier extent is about 5%. Drag along the glacier flow lines influences shape factor, which is roughly 12.5%. Then uncertainties of ice density, firn and neve to ice. Uncertainties in slope angle, vertical accuracies of DM, about 8 to 9% of errors are introduced. So you have uncertainties due to velocity estimates, creep parameter, shape factor, density of ice, and slope angle. So total add together, it's roughly about 18 to 20%. We have uncertainties in our calculations of glacier volume. And then the further, that's very important method, which is Gpr method, the radar method, that's ground penetration radar method. It does give us very accurate measurements, but there are certain issues with it also, like in case there are many layers and there are inhomogeneities within the layer, and there is a crevasse underneath, the topography and roughness of bed and snow firm layers interface is not correctly demarcated, then we have this errors coming of the range of 5 to 10% here also. And even small features in the bedrock topography can cause decadal scale variations in the ice dynamics response, and subglacier water discharge has been proven or has been talked about by some of the scientists. And now what are we looking for? From this, we got to know that we have a problem, that is how much water is stored in glaciers. Its estimates are not good enough. And then we also found out that we have different methods with us, but each of these methods have got inherent limitations and the errors are many. And we are looking now for something that is quicker, less expensive, that we can measure and eventually predict how glaciers would behave in future. And what is still missing till now is lack of fine resolution information about the topography underlying flowing glaciers, amount of ice and fresh water which govern the flow of the interior ice. This is also a very important factor which we have sort of totally ignored so far. And we need to model behavior of glacier accurately. So these three things have to be looked into. And our immediate requirement is to obtain information on snow water equivalent, snow melt onset of different basins and sub-basins, measure accurate ice thickness of flowing glaciers and to determine bed topography and basal conditions, develop ice flow models and generate accurate estimates of water available in our glaciers and its availability rate under changing climate conditions. And these 2 points I will discuss subsequently, but just for the sake of completeness, we have to miniaturize our radars because they are very bulky as on date. It's not possible to carry them to the glaciers. You have to make use of UAVs for getting this information. And this continuous satellite observation of surface elevation and surface velocity has to be a continuous process which is going on today, but it has to be done continuously. Then I will now bring the 2 experiments that has been done by my team, me and my team some time back. We tried on 2 glaciers. One is called Patio Glacier and other is in the Karakoram region in the Ladakh mountains. We tried the experiment. We tried all these methods which we discussed just now and I mentioned about them. We tried satellite method and GPR method using quasi-core technique for Patio Glacier estimation, volume estimation. Similarly, for Karakoram Ladakh, we use satellite as well as area volume and quasi-core techniques. And for snow depth, we used passive microwave satellite data and some field observations to get the snow estimates as well. But before we go into the details of these experiment results, I would like to mention that we have to take this thing now, we have to make use of the technology which is readily available now. Like people have now started using Airborne Gpr, which is shown in this view graph on the right side. The Gpr that we used earlier is of roughly about 6 to 7 kg weight, and we could fly it on some of the glaciers and obtain the snow depth, as well as we could obtain the buried depth of buried objects and the hidden crevasses, and some more information besides snow depth. And similarly, for using some hyperspectral sensors in the range of 0.4 to 2.5 micrometers on board these UAVs, we can get grain type as well as type and size, which will eventually get to know the snow wetness, which is very important for assessing the onset of melt water or melt season from the Himalayas, and as well as the contamination that is existing. So we have to use this technology, and finally we have to use the same technology for putting on this UAVs ice sounding radars, roughly in the range of which work in the dual frequency range of 7.5 to 14 megahertz. And then we have to also use ultra wideband radars for snow thickness and density. So I will now first give the results that we obtained from the experiments that has been done. The first one is the experiment done in the Patio Glacier, where we estimated the stored water in this glacier, which is roughly about maximum is about 278 meters thick at its maximum point. But from this graph, that is adjoining graph, you can see that the glacier bed topography is shown. You can see it's not so smooth as the glacier surface is going smoothly up, and the bed topography is up and down. So as such, if we calculate the mass using simply satellite data, that means power law relationship, will be doing many errors will be there, and we'll be estimating wrongly. And having done this exercise of using the satellite method, using the methodology which is shown here, we have found out what is the GPR retrieved glacier depth as well as satellite estimates depth. And you can see, though there is not much variation, still the variation that you see is still there. In GPR estimates are some places it's more, and satellite estimates are some places it's more. The GPR was taken right from bottom to the top of the glacier to take the measurements of the small glacier to get to know what is happening there. So this is the error estimates is so much, and roughly we found that there has been aerial change of about from 4,413 is about 0.212 square kilometers. Retreat has been of the order of this 0.0235 square kilometers. Change in thickness has been about of the order of 1.74 meters, and annual thickness changes are roughly about 0.21 meters. This is what has been published, and we have been able to do it with all the techniques which are available as on date. The glacier mission has been drawn. This is one technique. This is one area where the work has been done. There is similarly another area which is in the Siachen Glacier region and the Karakoram Mountains. Attribute a small glacier was chosen, and where GPR survey was done, as well as the power law relationship for that glacier was, used to estimate the glacier volume, and also the relationship that we draw using quasi-core method and this velocity depth estimation, the Glen's law. All the three were used, and we found that satellite estimate thickness and the GPR estimate thickness in the graph it's shown here, you can see that though there is a small scatter, nevertheless it's giving a fairly good match so far as the estimates by the two methods is concerned. So GPR is still taken as the better method, where we get fairly good estimates of the depth of the glacier. But the point, the only drawback with this GPR method is that it's a point observation, so you have to take many point observations, which is sort of impossible at times to do in this glaciated terrain. So this GPR has to be taken on board and upper this UAV, then only it's possible to take the measurements of an entire region. So overall, the ice volume of the Karakoram Glacier has been estimated of the order of 1,607 cubic kilometer, which is 1,473 gigatons, and which is equivalent to 1,473 cubic kilometer of water equivalent. This work has also been published. Now, having done these two experiments, and then we use this advanced microwave scanning radiometer AMSRE data. We resampled the whole thing from this 2012-2018, brought it to 5.5 kilometer resampling area, used MODIS data to get the area of the glaciated region, and then used snow meteorological data of some of the field observatories of surface from this period, 2012 to 2018. And using this data, it was possible for us to calculate the brightness temperature, and then brightness temperature was then related to the snow depth using an algorithm which has been mentioned here. We'll not go into the details, but we were in a position to get to know the snow cover, that means snow which is available in this region where the experiment was done. So, so if we know the snow depth, total snow depth for a larger region, we would be also in a position to know and draw an estimate about how that snow melt water will be available in different basins and sub-basins. So doing this work is not possible manually. So we have to make use of the technology. That way we will be in a position to draw better estimates about how much water is available and what rate it's available. And finally, the GPR I was mentioning that we had taken the GPR on board in helicopter, and we had placed it on a helicopter. The sample scan was 502 time window scan, and then we had used average diagonal constant of the entire snowpack was estimated about 1.5, and helicopter was maintained at the height of 40 meters, which was very difficult. But nevertheless, having done this exercise with 350 megahertz GPR antenna, we could estimate the snow depth at different altitudes, and it's shown here in these three graphs, the three profiles that we have taken of the glacier, that is Samudra Tapu Glacier. And here it is the snow depth variability. So you can see that it's not so smooth line, and there is a lot of variation as we move up. Even at higher altitudes, the amount may be less, snow depth may be less, and sometimes in the middle of the glacier, the snow depth may be more. So there is variability here, but we can get this we can capture this variability and bring out real estimates with this technology. Now, finally, what can be now done in this case is that we have a challenge. Challenge is that there is a lot of scattering caused by debris and water pockets in the ice, and large, often other clutter from the rough glacier surfaces as well as valley walls. The people have observed it, and it is sometimes very difficult. There is a solution that we can use dual frequency, that means 14.5 and 35 megahertz temperature ice sounding radar, which was developed some time back by Kansas University. I believe it has been now developed by some other people also. We can make use of this technology, and very encouraging results were obtained with 7.5 megahertz surface-based system in Greenland. And with this 14 megahertz frequency, and antenna weight was reduced to further 2.5 kg, and it was put on board in a small UAV, that is UAS, and they could obtain very encouraging results at 13.5 and 35 megahertz in Antarctica. So we know that technology exists and we have to make use of it. And similarly, ultra wideband radars for snow thickness and density measurements is possible. This SFC-W radar has been developed by in SAS only, and they could very easily, bring out different layers within the snowpack also. As layers as thin as 2 centimeters could be also delineated with the help of this SFC-W radar, this step frequency continuous wave radar. And in different frequency ranges, we can get different measurements. For snow measurements is 2 to 8 gigahertz. For surface elevation is 12 to 18, and for other measurements, ultra wideband micro radar 2 to 18 gigahertz have been used by people. So this technology is existing, and it has to be now embraced. It has to be taken up to Himalayas, and then we can use it. So the immediate need that's been felt by the people is to modify and optimize ultra wideband microwave radars with range resolutions of about 2 centimeters to measure snow, surface snow thickness, and snow water equivalent. And this can be easily taken up in US system, UAV system. The UAV system has to be modified. They have to modify and optimize instruments for collecting SAR data needed to perform 2-dimensional processing for sounding mountain glaciers. To miniaturize existing radars operating at 14 and 35 megahertz for sounding debris-covered ice in Himalayas. Then we have to develop airborne radars that can sound temperate debris-covered ice, as well proposed by Gogginini in 2014 and Loshen in 2014. To integrate regional climate model and downscale it to enable existing and new hydrological models to look beyond the present and predict future Himalayan water discharge. Then to study glacier dynamics at selected places using numerical models that incorporate boundary conditions determined from radar surveys, validate with INSAR measurements, which will be now available in our country also, and of glacier surface velocity. Then we have to integrate all of it together. That means we have to use a lot of remote sensing technology, integrate satellite, airborne, and use in situ measurements, which are not available at many places, but wherever it's available, we can make use of them of snow and ice in the Himalaya to guide the refinement, development of tools and techniques, and validation of hydrological models for better management of snow, ice, water resources. And finally, in conclusion, I have only one point, that there is now a need for a group of academic institutes to be sort of a forum made, or we could bring them together under some premier government institute like yours, and take up the task of regularly monitoring glacier depth, mass balance with the help of state-of-the-art sensors on board a lightweight upper air system, unmanned air system. Thank you very much for your attention, and it would be my pleasure to answer in case you have got some queries.
Thank you, Dr. Ganju. So it is very interesting to know that despite all the employment of the state-of-art technology tool, we still have a lot of uncertainties, and the variations are very, very far and wide. Like, sometimes you felt that even the Himalayan water flow estimates from 8,600 kilometers to 520, such a large range. It's amazing that the variation is there. So I'm really surprised that with all the technological developments happening in the world, why this part was sort of left behind it. And also understand why we had not been focusing on the glacier part of in the Indian context, because probably this is too difficult a subject and too complex a subject. That's why we left it to God, and then we are trying to grapple over it. Now, having said that, I just wanted to ask 2-3
Yeah.
questions before I can leave it to the other technical people to question. One, how do we stand vis-a-vis the other European and American and Arctic region countries in estimating the snow with thickness? Because and we have established permanent labs in Antarctica. We have a lot of inputs coming from the Alps mountain regions. What are the snow available there? How snow melting happens, and all this, and the volume of ice available there, etc. So how are they measuring it? And why are we not using it here in the first place? That's one. Second, are they also still grappling around with all these issues and still not able to find it? Because if you see the satellite imageries can show the depth of ocean bed, the layer by layer of water available in the ocean and all. But why is that it has not been able to get this in fact in the in these mountain regions? That's one part of it. Second is, if this so much of variation is there, is the study useful? Because it's like shooting in the dark. It may come correct, it may not come correct. So we are having a huge variation, and it's something like a guess estimate. So I mean, so is it actually really a scientific study which really going on? And you also mentioned a lot of theoretical part of it. How useful are it for us in the practical sense? These are 3-4 questions. Thank you.
Thank you very much. Starting with the first questions, vis-a-vis us in Himalaya, Indian scientists and Indian region, the scientists in abroad, what they are doing. As I was mentioning, all the algorithms, or I could say that indirect methods which have been given by the people, the majority of this work has been done by the scientists in different countries, including India also, but a majority of work has been done by the scientists. And the same algorithms or indirect techniques which have been developed by them have been used by us also, or the Indian scientists also, to draw estimates of the glacier volume or the presence of how much water is available there. That is one. Having known that thing, that these are just the indirect methods only, then the realization was felt by the people in other countries where glaciated region is, like in the North Pole and Greenland and Antarctica and Alaska, all these regions. They found that there is a need to have some better robust technique with us, with which we can make use of, we can draw a fair estimate of the glacier volume. So they tried different methods, but all these methods are a little difficult in a terrain which is slightly hostile everywhere. It's not in Indian Himalaya, maybe we have higher altitudes in comparison to other people, but the terrain is difficult everywhere. So it was earlier done using an aircraft, instrument and aircraft, and fly over the region, then obtain the data, which they have done for a good number of areas have been done, and fairly good estimates or good data is available, and fairly good projections are also drawn. But still, it's not possible to do for the entire region, which is very important for us to know. That's why they moved on to the next best thing, that is use the unmanned air vehicles. Because now unmanned air vehicles are used at number of places, and this is one area where they also attempted, and they found that simultaneously scientists have been working on miniaturizing these sensors, and they have been able to do that also. So when you put the sensors on board these unmanned air vehicles, then integrate the whole system, then you have hyperspectral sensor, you have Gpr also, you have and other sensors also, then it gives a fairly comprehensive picture in one go, and you can do it year after year. Number of things can. And in this part, this has not been yet. It has not been taken up in India yet. Primarily, maybe there is some initiatives required from somewhere, because there is slight resistance initially when we look at Himalaya, because it's not so easy. Even after having a UAV, people will have still to go to nearby glaciated terrain and then start flying it there, and there will be many issues. Many days are lost sometimes. So these are the things which are the estimates which you asked. The second point was that estimates that have been drawn by the people world over, the estimates that we have drawn for the Himalaya, you have seen that there is a variability. But there, one thing is there that even if there is a variability, there is some information available as on day. Otherwise, it was totally a dark thing. So with whatever technology, even with the error of 18 to 20% or 25%, we have got some values with us to start with. But in case we have to regulate water, as I am visualizing in future, for each basin, we will have to see how much water is available in terms of snow, how much water is available in terms of ice, at what rate it is available with monsoon, what happens, and with additional snow coming on top of it, what happens. If we have that complete information, then it is possible to regulate the whole thing in basin wise. And when we do that, then we will be having a total control on water as it is. It's something like we have an asset right now with us. We should be knowing what asset it is and how to use it in future, sparingly, liberally, in what way we can do it. That understanding has to be developed as soon as possible in this direction.
Thank you.
Ms. Neha, can you start the question answer session?
Yes, sir.
Please.
Good afternoon, everyone. I would like to introduce the format now. To ask your query, please click on the icon available on your screen. Raise your hand. Once you raise your hand, please wait for your name to be called. Introduce yourself first, your organization name, to ask your query. Now I request Mr. Pradeep Nayak. You may please ask your query.
Yeah. Well, I must congratulate Dr. Ganju actually to have given an excellent presentation. I'm Pradeep Naik from Rajiv Gandhi National Groundwater Training and Research Institute, Raipur. So, sir, my question is very simple actually. Do you see the temperature variation longitudinally across the Himalayas? And is it contributing to the timing of the snowmelt in different parts of the Himalayas? And what is the contribution of the timing of the snowmelt towards the stream flow? And second question is, how much the snowmelt thickness, snow thickness is related to Indian monsoon rainfall? And like, do you find any kind of relationship between the El Nino patterns or El Nino La Nina patterns in the Himalaya also, or it is not just significant?
Okay. Okay, thank you. The first question was the temperature variation in Himalaya. Yeah.
And the timing.
And the timing, yes. So one thing is very clear that, as I mentioned in the beginning, that there is the temperature variation exists in Himalayan in different regions, in different basins, across different basins. That is already there. But you see, as the onset of melting season starts, the valleys or the basins which are at lower altitude, they melt faster and they produce the snow melt which is existing there, or snow which is existing there, it starts melting. The first thing is that snow has to melt, which is the seasonal snow phenomena melting. And once the snow melt has started and a considerable amount of melting has already progressed, then the glacier gets exposed. Then the glacier melt starts. So in between, suppose we have another snow spell, even during peak Indian summer monsoon period, we have got some regions of Indian Himalaya receive snow also. So because of this fresh snow coming on top of the glaciers, then there is high reflectance from the snow and the melting stops. I mean, it reduces considerably. The snow melt has to progress, and then subsequently the glacier melt will progress. And this keeps on happening till the time this complete snow melt, which is snow, at least for the major portion, not in very high altitude region above 5,500 meters, where snow stays for a pretty long time. But in the lower altitudes of these glacial terrains, the ice melt starts. I think that was your question, or was it something else? Did I answer your question?
I request everyone to ask your query. Please click on the raise your hand option. Now I request Ms. Nupur Bahadur, you may please ask your query.
Hello, good evening. This is Dr. Nupur Bahadur from TERI. And first of all, I would like to thank Ashok sir for making this contribution and providing the opportunity last time and mentioning today, sir. Thank you so much. And to the speaker, sir, it was an excellent presentation, and the work, theoretical and the experimental work presented is highly valuable. I have, sir, one question which has two parts. First is that we recently had this, we are experiencing such calamities in the Gangetic region. So first is the probable reason what we hear is that the hydro energy projects in the basin, they are too much. So is this the reason, or you could provide a scientific reason for such calamities? And second part of the question is that that with these such studies, scientific studies, how we can mitigate such calamities? We can reduce the risk. So if you can provide an insight on this.
Okay, the first part of the question is related to the recent in the Chamoli district that you are talking about, that this thing has happened, and
Yeah.
do we have a fairly good understanding that what is happening and what can be done in case something is like that is going to happen? One thing is that we have it's a sort of large portion of Indian Himalaya is sort of a black box still. We don't have fairly good understanding or good knowledge of how the snow is available, how the meltwater is available. We have some gauging stations where we do collect data, but that is not enough. The understanding that we should have of the entire Himalayan region, that is not there. So as a result, we are not in a position to, come up with what is likely to happen in different regions, as has happened in recently in one of the regions. We don't have that much of data with us. It's my understanding. And if we have the knowledge, if we have the tool available to us with the help of which we can collect the data and then look into the data and then draw the inferences from the data, then we will be in a position to happening. All we know is that right now we know that there are regions in Himalaya where glaciers are melting, and some of these glacier water which is coming from this melt, glacier melt or snow melt, is further getting impounded by some lakes which are pro-glacial lakes or lakes which are in the adjoining areas of the glaciers, and they get filled with this water, and there is an apprehension that some of these lakes will burst, which we call GLOF. So this is an understanding we have right now today, but we really don't know, whether these glacier lakes which are existing, are they really going to burst, or there is going to be an overhead erosion and there will be water flowing downstream in no time? Is that going to be the scene? So if such things are there, then we will be in a position to, such tools are available, we'll be in a position to draw some useful information. So presently, I would say it is the paucity of data, understanding that we are not in a position to draw some useful deductions about that's what is happening. And in case we have this information with us, we will be definitely in a better position to draw inferences about what is likely to happen in case we have more dams coming up, or we have because I am also of the opinion that we may have to, if we don't allow this water, glacier water, to go as a runoff and then it's unutilized and not used by the people, it just goes straight down. We have to have a mechanism where it can, the meltwater can replenish the aquifers, replenish the springs, replenish the lakes, instead of going it down. So we may have to create some embankment somewhere or weir somewhere or something, so that this water is taken in by the earth and replenish these systems, water systems which are existing. So I'm of this opinion we will have to do some interventions like that. but it is possible only when we have a lot of information which is not existing as on date with us.
I request Mr. P. Dorje Gyamba from CWC. You may please ask your query.
Thank you, Ganju sir, for the wonderful presentation. Really, it was a very lot many things learned for us to learn about the Himalayan, the natural resource, water glacier from glacier and ice. My question is in one of the slides regarding the Patio Glacier, you have shown the glacier bed topography, right? It plays a very good role in retention of glacier and melting in melting also, because when there in that Patio bed topography there is an arch and there is a gap. Generally glacier fill that gap, and upper surface we find a smooth surface. Whenever there is a melting, in my personal feeling, because I belong to an area very close to Tibet border, where glacier and avalanches are quite common phenomena in that area. The water, whatsoever melt, it will first collect it in that particular topographical, the deep portion, and slowly when it gets filled, and when further. Now second issue is, when nowadays we are getting lot of rainfall in the month of February and January. Recent issues, we got a lot of rainfall in Satluj Basin also. When this heavy rainfall is being exposed to the glacier and snow, it makes slush. That slush will fill that particular depression, and up to some limit it will retain it. After that it will breach or it will come out from that particular day. Like this, is there any experience of damming the glacier or glacier in the Himalayas or in other countries? You have any experience in this? Like we have check dams in avalanches at the initial stages to stop the trigger of avalanches.
Yes. Oh, thank you, Mr. Dorji, for the question. Actually, if we, as I was mentioning earlier, if we knew the subsurface topography of all the glaciers which are in the Himalayan or prominent main areas region, then it would have been very good for us. We would have known how much, what are the different types of depressions or undulations existing in the subsurface. But presently, we don't have this information available at all the places. It's only at selected few locations where these experiments have been done, and we found that as is the understanding that glacier looks very smooth on top, it would be smooth at the bottom also, but that is not the case. There is a lot of there's a lot of variation. In subsurface topography as well. Now, your second part of the question is that would that depression that you had seen the Patio Glacier would get filled with water first? Actually, when meltwater starts, a lot of meltwater starts with the melting of the snow first and then the glacier. A lot of meltwater that happens or that flows is the supraglacial flow, that is on top of the glacier. The ice underneath, unless this meltwater goes into the body of the glacier at some place through a crevasse or some hole or moulins we call them, unless and until it goes through some hole or through some crevasse into the glacier, to the bed of the glacier, this water generally flows from the top and then comes out from the top region at the snout region. Nevertheless, some basic or subsurface flow always exists because of the heat interaction between the glacier and the earth underneath. There is a temperature, relative warm temperature, and some melting keeps on happening, and that happens throughout the year. But would in case something like that is happening, that water is going into the glacier at some point of time or some place, this will bring in totally new dynamics in the glacier phenomena. Glacier might flow as ice body itself. There will be a break in the glacier, or there will be water stored for a long time within a glacier. We call that end glacier lakes, which get formed. And it may burst, as you rightly mentioned, it may burst in some point of time. We would be not knowing exactly what is happening. We know now today about the Glob phenomena, where glacier water comes out of the glacier and then is stopped in front by an end moraine, and this water keeps on accumulating in that moraine dam lake, and it might get burst. But we don't know as on date what would be the state when this end glacier water is there, which will burst at some point of time. So for that, the understanding of the subsurface topography or subglacial topography is very important, and that can be achieved through this latest techniques which I was mentioning, technology which is available. I hope I answered your question.
I request Mr. Ashish Mitra, you may please ask your query.
Good afternoon. Namaste, Dr. Ganju. I am Ashish Mitra from NCMRWF, National Center for Medium Range Weather Forecasting. So it was an excellent talk and very informative, and all the latest information I got. So towards the last part of your talk, you have given a lot of new technologies, which is the hope for understanding, which will be the way provide means and ways to observe and take process studies and ultimately predict. But seeing the status in India, so there are a lot of things to be done, like the instruments, sensors you have suggested. So, and we have to do it very fast compared to many other neighboring countries, and there is a pressing environmental and strategic need. So from your experience, my question is, there are many government departments like Environment and Forest, Water Resources, Earth Sciences, ISRO, DRDO, even the Armed Forces. So who should take the lead? Somebody has to take lead, and of course it's a joint coordinated work. So I think we cannot wait more to take it as a big, massive project, but somebody has to take a lead. So you are having enough experience, or if you can give some clue, because somebody has to lead. That's what I feel. Thank you.
Yeah. I totally agree with you, Dr. Ashish. There is some institute has to take the lead. I believe that because of this ministry which has come up, we have a hope that the departments which are under this ministry or which come directly under it, they should be now taking the lead, like issues like NIH is there, and then CWC is there, because each of these institutes have got their own forte. And when it's working in mountain, the logistics and taking the things, doing things, definitely DRDO can help. In turn, establishment like SASE can also help. But and premier institutes who have the mandate of looking at water as a resource, where it is, how it's available, what's its use, how it will be available in future. So such institutes should be taking the lead, in this direction. That is my assessment. Other institutes are definitely, academia is also there, and other institutes are also there to help. But one such institute should be taking the lead.
I request Mr. Rudra Ramakrishna, you may please ask your query.
Thank you, ma'am. Hello, sir. It was a really good presentation. I enjoyed it a lot. I'm Rudra. I'm a civil engineering student from Reva University, Bangalore. So I'm in the final year. So I would like to know, how can I help in the future for water or the problems that India is facing in terms of field work, as well as what kind of courses that I could do in future to further my understanding to help out in a better way?
Thank you, Mr. Rudra, for your question. I mean, you can, there are a number of questions, unanswered questions, so you can pick up anyone and start working in that direction. So there is no dearth of work that can be taken up. But the important thing is that you have to I mean, prepare yourself for it, for which you rightly mentioned, you have to take up the courses. And there is no such institute in India which is regularly teaching or imparting a knowledge on courses on snow or ice or water as such. So there are some institutes like IIC Bangalore, the Devechya Center is conducting every year a course on glaciers, glaciology. It includes hydrology and everything else. So there you can approach them. And some time back, I have seen IIT Delhi also conducting some course. Maybe some courses are available with CWC or NIH. You can just inquire from them. So you have to first acquaint yourself with what are the tools available and what is the technology available. Having done that, then you can approach some of these departments and they can take you as a research scholar or a senior research scholar in whatever way it is possible, and then further keep working in that direction. That is the way generally it is being followed. So we don't have a regular mechanism of working in these fields. It's generally on-the-job training or some courses being done here and there.
So we have one query which is from Mr. Naresh Kumar, and he is asking that what is the extent of water supply that can be derived out of the Himalayan ecosystem, and how many stages will the implementation involve?
Could you please repeat the question? I didn't get it.
What is the extent of water supply that can be derived out of the Himalayan ecosystem, and how many stages will the implementation involve?
What extent can we derive water? I don't see that we can really derive water from Himalaya. It is the water which is available there in a frozen form is snow and ice. Now, this water naturally, because of the natural process that is happening in the Earth system process that is happening, it naturally melts and naturally gets into the river systems downstream. This water is available to various people for hydropower projection and then irrigation and some domestic use, and everywhere this water is. The majority of this water is unfortunately going out as a runoff, and then it's going down. So we have to at what stages can we intervene? It is a job of a civil engineer. In case we have to irrigate an area, we may think of a small dam, or in case we can put some water on some hydropower project on the run of the river water run, and then have an hydropower project coming on it. There are different ways to do it. So it is not, we cannot take the water which is already available there and releases as a melt water, as a snow melt water. Whatever way it is coming, we can just use it. So the trick is that how best can we use for our own consumption.
I request Mr. Jose Potekal, you may please ask your query.
Thank you, Ashwagoshi Ganju sir, for your comprehensive presentation. I remember that around more than 7 years ago, there was an online meeting with Professor Gogineni regarding a pilot project for UAV in the Western Himalaya and some selected glaciers, Chota, Shikari, Patio, and etc., in which I also participated. I'm presently working in NIH and posted at Jammu, Western Himalayan Region Center.
Okay,
Yeah,
okay.
so
I know you,
I remember that meeting in which IIT Bombay and I think your Snehmani also participated.
Yeah.
I remember where you were there. But there were some issues there at that time that could be overcome, the defense related issues and all, or UAV.
No, it was started as a NSF project, and
Yeah.
we had to take the clearance from the government, US government, for this project. And US government at that time was not very keen to give this project to us. So that's why it got stalled.
Otherwise, defense was okay. Our defense.
There was no issue for defense because I was there, so I knew it from defense point of view how we are going to tackle it. So we were not really, defense was not an issue at all. And Gogini has a technology. He knows how the sensors have to be put on board. He has a fairly good understanding of the US system. And he had worked in some of these areas, Norway and all these areas. So he was a very good person, potential PI for doing this project. But because of this thing that it could not go through it. So now the point is that in case we want to do it and we want to take it further, Dr. Josh, so we will have to use the resources within. We can still tap the Mr. Dr. Goganeni for help, or there are many other people who would be ready to help us. But then we have to tap our own resources in manpower, as well as technology, as well as the resources in terms of funds to do this project for our Indian Himalayan part. So that is what I can say at this stage.
One question which came to my mind. See this, Dr. Ganju. See this. There was a study of the Intergovernmental Panel on Climate Change in 2019, which said that about 1 to 4 degree rise of temperature would be there in the Hindu Kush range, Himalayan ranges by mid of 21st century, and also about 2 to 6 degree by late 21st century. So this is a very, very important study where it says that the temperature will rise up to 6 degrees. So even if you do not know what is the extent of snow available, I mean, where the bottom edge of the ice, if this increase in snow, what would be the, increase in temperature, what would be the volume of water which will be melted and flowing down the river? Can you have any estimate on that?
It's very difficult to draw an estimate like that, but there will be substantial increase in water flow. It will be certainly, if the temperature increase will be it's of the order of 4 to 6 degrees, which is very high. It's very high. That means there will be suddenly a lot of water available. And then after this burst will be there, the sudden water burst will be available, the rivers will be in spate, everything will be flooded, sort of thing. After that thing is over, then there will be a sudden drop. And that drop will be substantial, and then there will be very less water available there. So, but these are all projections, and these projections are not, they are taking scenarios, they are taking different scenarios into consideration. This scenario is very extreme scenario, which is very difficult to comprehend at this stage, whether it will happen or not. But we should be, from our side, we should look into this possibility. In case we have to have a scenario like this, what are the things we need to look into? That's it.
So we have now last query, which is from Mr. Naresh Kumar. He is asking that what are the factors other than technology that can help in the sustenance of the Himalayan ecosystem?
For the ecosystem, Himalayan ecosystem to sustain is, perhaps I'm not the right person to answer, But I will say that the climate change as it's happening is because of the greenhouse gases, and we know blah blah, everything is known. So if we can somehow do something with the reduction in the greenhouse gases, plant some more trees in the areas, and have this water which is available, not allow it to go as a straight runoff, use it, develop micro systems within localities or areas where naturally the whole system will heal up. This is the way we can sort of bring back the health of these glaciers and the glaciated system. But I think Mr. Naresh Kumar can put this question to some environmentalist, and maybe they will give better insight to him of how we can do it other than the technology intervention, which I talked. And mine was not an intervention, it was only knowing what amount of water is available to us and how it's available to us.
Okay, thank you. We can close it. We can close the meeting. Neha.
Yes, sir. Sir, but we have one question, but this is for you. This is from Mr. Gopal Singh. He is want to know that what kind of support does National Water Mission and team help for the innovations in saving water?
Oh, that's a lot of things that is not related to this topic anyway. So we saving water, we are doing a lot of work in the demand side as well as in the supply side. We in the demand side, we are conducting studies on water audits in industries, also trying to study the water use efficiency in irrigation sector, so that the appropriate step can be taken to increase the water use efficiency in agriculture. We're also trying to promote the use of micro irrigation systems and better irrigation techniques and technologies so that the water use efficiency increases. So that's in the agriculture side, and the industry side. Auditing is being done so that steps can be taken to study and recommend suggestions to reduce the water usage. We're also promoting the 4R, the 3 Rs, the reduce, reuse, and recycle methods for saving water. We also conducting a lot of seminars and experience sharing sessions to research to use the wastewater properly, to substitute these type of treated water for in place of potable water, so that the potable water can be saved. So even one of the tech talk last time was from the Swedish Institute for how to use wastewater for various purposes after treatment. So this is a lot of things we do on the demand side. Supply side, of course, we have this campaign running, Catch the Rain, where it falls, when it falls. We look at various ways how to conserve water. We help in information dissemination of best practices in various parts of the country, and through our water talks, we bring activists, we bring their experience from the field so that others can learn from it. On both supply side as well as demand side, we try to provide platform. We are not providing funds as such, because we try to coordinate with funds various agencies, because Catch the Rain campaign primarily is run on the Mandrega funds as well as funds from the Finance Commission, to the district mineral funds, etc. So we are not a funding agency as such. We try to get people together, like what we today, if you look at it, Glacier was one area where people had just Nazarandas karke rakha tha. Nobody was really looking into the glaciers part of it. We are trying to bring this focus. This talk was actually scheduled 3 months back almost. So when the glacier burst happened, we thought we'll look at the water availability in the Himalayas, and also look at the ecosystem and the environmental problems associated with climate change and water, we should try to bring in the focus. So our endeavor is to get the issues focused and bring a discussion on it, and so that the appropriate authorities take the right steps to go forward. So today, definitely, as Dr. Ganju has said, a lot of suggestions which has come up, and there is no single agency actually studying the glacial issues in the country, even though once or twice we had meeting at Niti Aayog doing something on glacier, but nobody, the glacier is actually nobody's baby. So we are trying to bring it into focus and telling that, yes, there is something sitting on our head which can happen, can cause disasters to us. And the basic information itself is not available on how much water is available, how much ice is available, and how it is melting, and what are the effects of it on the ground. These are basic things are also not much clearly known. So we try to bring a focus, a spotlight on this issue, and then probably people like you who are listening, or people, this we put in our website also. A lot of people watch our website nationally and internationally. So they also would like to get it flagged up. So that is what we are looking at. So as of now, as I said, we are not a funding agency. We try to provide platform. We try to involve everybody in the thought process associated with various factors associated with water and climate change. Thank you.
Thank you, sir. Now I request Shri Sunil Kumar Arora, Advisor CNM National Water Mission, for the vote of thanks.
A very good afternoon to all of you. On behalf of National Water Mission, I extend a very hearty thanks to all of you for sparing your valuable time for attending this 8th Water Tech Talk. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion of such an intellectual delegate. The inception of Water Tech Talk has been initiated, as you all know, that from 9th of October 2020, and this is the 8th Water Tech Talk in that series. We are grateful to our Additional Secretary and Mission Director, sir, for his able guidance, which has always encouraged us for organizing Water Tech Talk series. He is the driving force behind this talk series. I hope you all must have enjoyed this session of Water Tech Talk, as well as experiences shared by the speaker, Mr. Dr. Ashwagoshi Ganju, former director, SASE, that is the Snow and Avalanche Study Establishment. Mr. Ganju has completed his master's with honors in geology from Punjab University, Chandigarh, and his doctorate from Pak University of Technology, Chandigarh. He obtained a formal training in the field of snow science from Swiss Federal Institute for Snow and Avalanche Research, that is in Switzerland, in 1995. I owe special gratitude and sincere thanks to our special guest speaker, who, despite his busy schedule, found time to enlighten us about the tools for resolving indeterminate snow ice resources for the sustenance of Himalayan ecosphere. His presentation brings out the main knowledge gaps and suggests remedial action that need to be taken for the sustenance of Himalayan cryosphere, citing the new technology that bring out the necessity of an action plan that would help in collecting data using UAS with onboard ultra wideband radars. He had a lot of awards and medals in his kitty, and today we came to know about the method used for glacier volume estimation, like area external method, confirmation method, area extent method, and then the cozy core, globe top, HF model, so many other models. We came to know about the method used for glacier volume measurement. We are lucky enough to get the knowledge on snow ice from such an experienced scholar. I also express my heartfelt thanks to all of the attendees for joining this session of Water Tech Talk on virtual platform, and had a patient hearing to our speaker to make this event wonderful and successful. I also convey my thanks to Team Water Digest and Team National Water Mission for giving their wholehearted support in organizing this Water Tech Talk. Thanks to all of you again, including attendees, for making this Water Tech Talk a resounding success. See you all in the next episode of Water Tech Talk next month on 11th June 2021. Till then, goodbye, take care and stay safe. Thank you very much.
Thank you. Thank you. Thank you very much, Dr. Sunil.
Thank you.
Dr. Ashok Kumar, for giving me an opportunity. Thank you very much.
Thank you. Reminding all of you that next Friday, same time, we'll have the water talk. One eminent person. So please welcome all of you for the next water talk, the 26th water talk next Friday at 3 p.m. Thank you.
Thank you, sir. Thank you all.